All right, let's jump right in. Today, we are talking all about exception handling. Now, I know what you might be thinking. Oh, you mean try-catch blocks? And yeah, sure. But it's so much more than that. What if I told you that how you handle exceptions is actually one of the most critical parts of system design? We're going to completely transform how you see exceptions, taking them from just a simple coding task to a core strategy for building systems that are, well, basically unbreakable. Oh man, we have all been here. You know that feeling, right? That pit in your stomach in the middle of the night? A critical service is down, and the logs are just useless garbage. This quote just nails that feeling, that pain caused by bad exception handling. It's the scenario every single one of us dreads. And here's the thing, it's almost always preventable. And this is the real question, isn't it? Because poorly handled exceptions aren't just little bugs. Nope, they're ticking time bombs, buried deep inside your system, just waiting for the right moment to go off and take everything down with them. The threat isn't some outside force, it's already hiding in your codebase. So why do we call this a system design problem? Well, because every single time you write throw or catch, you're making a decision. It's a communication decision. It's how your system's different parts talk to each other when something goes wrong. And if you get that language right, your system can fail gracefully. But if you get it wrong, it fails catastrophically. This slide really lays out the stakes. On the left, you've got the total nightmare, failures that are completely silent, going on for months without anyone knowing, logs that just make things more confusing, and one tiny error that brings the whole system down like a house of cards. But on the right, that's our goal. Failures you can actually predict, logs that tell a clear story, and systems that can bounce back all on their own. Okay, let's get into the nitty-gritty. We're going to break down some of the most common traps that developers, and I'm talking even very experienced senior developers, fall into all the time. These aren't just rookie mistakes, they're subtle anti-patterns that have kind of become bad habits across the entire industry. First up, rethrowing an exception. It sounds so simple, right? But how you do it is absolutely critical. Logging an error and then passing it up the call stack is a good idea, but one tiny little syntax mistake can completely sabotage your ability to debug anything. And boom, here it is. This is the whole thing. On the left, you see throw X. That little x, it's so dangerous. It completely resets the stack trace, the map of who called who. It makes it look like the error started right here, hiding the actual root cause. But on the right, that simple throw with nothing after it, that preserves the entire original map. It gives you this perfect trail of breadcrumbs right back to where the problem really began. And that is not an exaggeration. I mean it. That one tiny change, that one word, is the difference between a 5-minute fix and a 4-hour nightmare where you're just guessing which service is actually on fire. It's that important. Okay, next up is one of the most dangerous habits out there, swallowing exceptions. This is when you have an empty catch block or maybe just a comment inside that says, "To do, handle this later." It's literally the coding equivalent of seeing a gushing leak in a pipe, slapping some duct tape on it, and just walking away. You've hidden the problem, sure, but you haven't fixed a thing. And here's a perfect real-world story of the damage this causes. There was a background job that was supposed to send out notification emails. It was failing, but the exception was just being caught and ignored, swallowed. This temporary fix was put in 8 months ago. For 8 months, customers were not getting their order confirmations, and the business had absolutely no idea. They were completely blind. All right, so let's say you're doing the right thing. You're creating your own custom exceptions for your application. That's a great start. But here's the catch. A custom exception is only as good as the information it carries. If it has no context, it's really not much better than a generic one. I mean, this slide says it all, doesn't it? The poor exception on the left just says payment failed. Okay, thanks. But what payment? The rich exception on the right, though, it tells you everything you need to know. The exact transaction ID, which payment gateway was used, the amount. You can take this info and immediately start investigating. You can filter logs, check Stripe's status page, and find the issue without digging for hours. So up to this point, we've been really focused on the code itself. But to get really good at this, we have to zoom out. We need to stop thinking like we're just fixing bugs and start thinking like an architect who's designing a resilient system from the ground up. This is all about strategy. And a huge part of that strategy is understanding that not all failures are the same. You absolutely have to separate them into 2 main buckets. Transient failures, these are temporary hiccups like a network blip, and fatal failures, which are permanent problems like trying to process garbage data. They each demand a totally different response.
This table makes the strategy super clear. For something transient, like an API timeout, you retry it. But you don't want to just hammer the service, so you use something called exponential backoff. You wait a little bit longer between each failed attempt. But for a fatal failure, like corrupt data, retrying is just a waste of time. It's going to fail again. So the right move there is to fail fast, log it, and tell a human something is seriously wrong.
So now, let's talk about a really powerful pattern for designing for failure, the circuit breaker. Instead of just reacting to exceptions after they happen, this pattern uses them as a signal to proactively protect your system from a failing service and stop a small problem from turning into a total system meltdown. It works just like the circuit breaker in your house. At first, the circuit is closed and everything's flowing normally. But if too many calls fail and hit a certain threshold, the circuit trips and opens. When it's open, all requests fail immediately without even trying to call the broken service. This is key. It gives that service time to recover. Then, after a timeout, it goes into a half-open state. It lets just one test request through. If that one succeeds, great, the circuit closes again. If it fails, it stays open.
Whew, we have covered a lot, from tiny bits of code syntax all the way up to big architectural patterns. So let's pull it all together into a really practical checklist that you can start using like today to make your code and your systems better.
Okay, at the code level, these are your rules to live by. First, stop throwing generic exceptions. Be specific. Second, always preserve the stack trace with a simple throw. Third, only catch something if you can actually do something useful with it right there. And a big one, never ever swallow an exception without at least logging it. And finally, make your custom exceptions work for you by packing them with useful context. And then at the system level, you gotta think bigger. Don't let your internal messy exceptions leak out of your service. Design your logic around that crucial difference between transient and fatal errors. Centralize your exception handling in middleware so it's consistent. And for any important service you depend on, protect yourself with a circuit breaker. You know, this right here, this is the whole point. Let this one sink in for a second. The goal is not to write code that never has an error. That's impossible. The goal is to design systems that use exceptions as an intentional tool, a powerful signal to make failures obvious, to trigger recovery processes, and to turn debugging from a guessing game into a science. So I'm going to leave you with this one last thought. The very next time your fingers type out the word throw, just pause, just for a second, and ask yourself this question. What am I really trying to say right now? Answering that question with intention is the first step toward building truly resilient software.